Then I will now proceed to explain the topic of seemingly unrelated regression, which is a case where we have multiple equations, each with its own distinct y variable. So I'm going to illustrate this with an example from the field of corporate finance, specifically concerning a company's particular policy. For this, I'll be utilizing information from the Finance ResearchGate website, focusing on a signal frequency, reported annually. I will begin by quickly selecting the entire relevant period, and following that, I will then choose the appropriate x variable. Now, the first equation we are considering is directly related to the dividend yield, while the second equation is specifically connected to long-term share issuance. The first set of factors that we'll be looking at will be related to the payout policy. I'm going to choose the EPS persistence indicator, and the other one is the EPS predictability. I'm also going to be selecting the cash flow to price metric. And I will also select several key variables that are primarily connected to the long-term issuance of shares. Specifically, I'll be selecting the book-to-market ratio, and I will also include the market leverage as another important factor. Now, since we have two y variables that we need to consider, and within this particular selection box, we are only able to choose one, we're going to select one of the y variables right here within this box. The second y variable, however, is located in a different place. Therefore, you are presented with these two distinct options. Okay, so the SUR section will allow you to specify the x variable as being dependent on a y variable. Therefore, I can easily select both of the y variables right here. And the very first one that we'll consider is the dividend yield. The other important aspect we need to consider is the long-term issuance of shares. For this particular scenario, we've gone ahead and selected all the relevant x and y variables. We can simply leave this particular setting as its default value for now, even though it means we're selecting a variable that we won't actually be utilizing in our analysis. With that out of the way, we are now ready to proceed to the next step. So now, to find the seemingly unrelated regression, you have two main options to consider. You can either scroll down through the entire list, or you can use the Control F shortcut and then search for SUR to locate it. And this is the specific part of our analysis where we are able to estimate multiple equations simultaneously. And here we present the comprehensive description for your consideration. Then it will be necessary to enable this particular section so that you are able to commence the application of the SUR. What is the SUR? It stands for Seemingly Unrelated Regression. This refers to a situation where you might have two or more equations that at first glance appear to be completely separate, but in reality they are not entirely independent of each other. This indicates that the other term we're discussing would exhibit a correlation across all of the equations. So looking at the first equation, we are specifically examining the payout policy. And then for the second equation, our focus is on long-term share issuance. At this point, it's important that we Winsorize all of the variables, mainly due to the presence of outliers. However, for the purpose of illustrating the methodology itself, rather than focusing on the precise interpretation of the coefficients, I will simply move forward swiftly and conduct the analysis without applying any Winsorization process. Nevertheless, it is important to note that we absolutely should perform this step given the presence of several extreme outliers in our data. Alright, so for this particular step, I'm going to select the dividend yield. It's important to note that you have the flexibility to choose the x-axis as a y variable. Therefore, this will serve as our primary y variable in this particular setup. And for the very first x-axis variable, I'm going to specifically choose the cash flow to price ratio. Furthermore, I'll also proceed to make a selection for we're considering the persistence of earnings per share and the predictability of those earnings. These are primarily related to the concept of divinity. You are certainly welcome to include additional variables if you wish. For the second variable, it's important that it utilizes distinct y variables. Consequently, in the SUR framework, you'll need to have a minimum of two equations, and it's essential that each of these equations is assigned a distinct y variable. So, I'll select the long-term share issuance and then a potentially different set of regressors. The regressors that we are considering here, they are not exactly the same. At least one or two of them should be distinct. In fact, at least one must certainly be different. So, I'm actually going to... For this particular scenario, we'll select the book-to-market ratio, market leverage, and cash flow as our key metrics. Therefore, the common independent variable in this analysis is indeed cash flow. However, ultimately, we will be working with two distinct equations, each possessing its own unique dependent variable. The fundamental idea here is that individual firms may possess certain firm-specific effects or experience particular events or shocks over time, and these factors would inherently be correlated between the two equations. For example, if we experience an abnormal profit debate during a specific period, this situation will likely result in a higher dividend payout ratio for that same period, and concurrently a reduced necessity to raise additional equity for funding purposes. Consequently, the initial error or the unexpected shock occurring in that particular period directly influence both of the equations, specifically impacting the two y variables. This specific scenario will undoubtedly result in the emergence of a significant cross-error covariance. Therefore, it suggests that the inherent error term associated with the first equation might indeed be significantly correlated with the error term found within the second equation. This particular cross-covariance, which arises from the error terms, is an absolutely critical factor that must be fully incorporated into our analytical framework, and therefore it absolutely needs to be meticulously modeled. So, in the seemingly unrelated regressions model, we are going to specifically employ the error variance covariance matrix that arises from these particular errors in order to properly weight each of the observations before we proceed with determining the coefficient estimates and their associated t-values. This particular scenario does not align with the fundamental assumptions of OLS. Consequently, for this specific situation, it will be far more efficient or indeed more suitable to implement the SUR approach. Well, I should go ahead and execute the SUR routine. And so we have here for your consideration the first of these important equations and then the second. So for the very first equation we looked at, we had the dividend yield, and these are the variables that predict it. And this is what we do for the second equation, so that you can have them all consolidated and clearly visible within a single table. Now, if you look at the coefficients, we do have them. If we were to apply OLS separately for every equation, we might choose to concentrate our focus specifically on the variable of cash flow. Let's focus on the price variable here, for example. We need to carefully observe if this particular value changes when we consider the second equation. Therefore, I will now proceed to execute the ordinary least squares regression for each individual equation. So, as you can clearly observe, the coefficient might indeed be subject to change, given that its current value stands at negative 0.0014. The t-value, which was previously noted, is now negative 5.19. But returning to our previous discussion, it is almost the same coefficient, but in this particular instance, the t-value is quite different. So the coefficient itself may or may not actually change, but the t-value, that's the key factor we need to consider. This also has the potential to change as well. So if we look here, you can see the entire error variance covariance matrix that is presented down here for our consideration. And we note that it is not statistically significant because the covariance value itself is really not that large in magnitude. However, this issue truly does exist, and its presence can indeed cause noticeable differences in the coefficient estimates and also in the t-value calculations. This specific point is particularly important for the SUR model. Thank you for watching.